I'm going to start with solving case 4 instead of the other cases. I'm doing this out of order. I'm starting at the very end because case 4 deals primarily with, it deals exclusively with chapters 10 and chapter 11. The other questions get into a mix of 11 and 12. So this is a good place to start off with looking at hypothesis testing, which makes up part of this question, and estimation or confidence intervals. And so you can see here that the question has 4 or 5 different parts from A to E. And some of this is going to come from chapter 10 and some of it's going to come from chapter 11. And actually some of the questions here, specifically C, is going to be a mix of 10 and 11 in a way that you don't actually see in your textbook. So I'll be introducing maybe a new concept here for you, unless your professor went over this in the lecture slides. Normally chapter 10 and 11 are kept as separate in your textbook in the way that it teaches it. So there'll be some interesting stuff here where they get mixed. Okay, so anyways, I'm going to be focusing on chapter 10 and 11 techniques. Now these two chapters deal specifically with estimation, that's chapter 10, and chapter 11 deals with what's called hypothesis testing. And both of these have something very specific in common. These both deal with what's called inferential statistics. So inferential statistics, I'll just call it inferential stats here, is going to be a situation where there is an unknown, and it's going to be a population unknown. There's going to be some kind of a value in the population that we're going to be asked about, and our job is going to be to figure out what we think is true about that unknown population value. Now we're never going to be able to figure it out directly. We're not going to be able to look at the population. Instead, we're going to be given a sample, so you can see that there's a sample here. In fact, there's a sample of size 20, so n equals to 20, that's my sample. So we can take a sample from the population, and that's going to hopefully give us a good idea as to what's going on in the population that we cannot measure directly. So let's have a look and see what the question itself is about. The mayor of Vaughan claims that the average commute by residents of Vaughan is 140 minutes per week. Okay, so far we've got a claim. So we don't know if this is true, it's just what's claimed. And the claim deals with the average commute. So there's a claim about the average commute. I'm doing population average here because the mayor is not making a claim about a sample, he's just making a claim about the residents of Vaughan. So that is all residents of Vaughan, which means it's the population of residents of Vaughan that he's making a claim about. And he claims that the average is equals to 140 minutes. Now normally I'm not going to bother with writing in the units here like minutes, but when I'm reading through a question, it's really important to make sure that I understand, or that I'm checking to see whether or not everything is in the same units. For example, if they start talking about hours later on, I need to convert that to minutes. Or I could convert my minutes to hours. You just need to make sure that whatever your units are, you've got the same units the whole way through the question. So he's making a claim, which means we don't actually know whether or not this is true. And we're not going to be able to check out whether or not it's true by looking at the population. Instead, as I mentioned before, we're going to be given a sample, and we can use the sample simply as evidence. Evidence either that's going to suggest that this is true, or evidence that is going to suggest that this is false. So let's see which one, or let's see how they carry on here. It says a random sample of Vaughan residents were asked how many hours per week they spent commuting. Okay, so a claim is made about their commute, and now people are asked how long they spent commuting. And it then says, if it's known that all Vaughan residents produce a standard deviation of 44 minutes. So all Vaughan residents, again, here's reference to the population, and the standard deviation in the population is written as sigma, and that's equals to 44. Again, it's in the proper units. So I would say that my standard deviation is given, because it said it is known, and here is my claim. That's going to end up being a hypothesis. And what else do we know? Oh, here. It says the following are the results. And as I mentioned earlier, in our sample, we know we have 20 individuals. So we have a question about the population, we have something that we know about the population, and we also have some information about the sample. We have the sample size here, but we also have all of our observed values from the sample. So later on, that's going to become really handy when we have to do some calculations of some sample statistics. In other words, we're going to find some summary values. We're going to find the sample mean. We're going to do that based on our simple formula of adding up all the values and dividing by n. But let's do that when it becomes necessary. Let's start off by looking at Part A. Part A says, what is the null hypothesis if we were to test the mayor's claim? All right, so let's have a look and see how that works. Now, a null hypothesis is a Chapter 11 concept. And in Chapter 11, there's always going to be, as I mentioned earlier, a population parameter. In the case of Chapter 11, it's always the population mean, and it's going to be unknown. The whole idea of all of your work, all of your chapters after the midterm, is that there's going to be some sort of a population parameter that's unknown. So in Chapter 10, it happens to be the population mean, so it happens to be this value here that we're going to be interested in determining. In fact, this is also the same for Chapter 10, but Chapter 10 deals with estimating this number, whereas in Chapter 11, like we're dealing with for Part A, we're going to try to guess at this value. Now, we don't have to make the guess ourselves. In fact, the guess is going to be given in the question, and it's given in the form of a claim or what's called a hypothesis. And a hypothesis comes in two competing versions. So it's going to be one or the other. They can't both be true. The first one is called the null hypothesis. It makes a statement about what we believe that the mean is equals to. And in our case, in the case of case number 4, the claim is that it's 140 minutes. This is the claim that the mayor makes. So this is my null hypothesis, and this is the answer to Part A, as simple as that. My alternate hypothesis, remember how I said it has to be a competing hypothesis? My alternate hypothesis is that the mean is simply just not equals to 140 minutes. So this takes care of everything. Either the mean is or is not 140 minutes. This is just a guess, but it's an educated guess we're going to be making. We're going to go through some mathematics and look at the probabilities that either the null is true or the alternate is true. We're going to do that based on what evidence we see in our sample. But to set it up, we need to have these two competing hypotheses. In Part A, they don't want both of them. They just want the null hypothesis. So this is it here. The null hypothesis is that the population mean is equals to 140 minutes, or you could leave, you don't have to write the minutes, that part's not really important, as I mentioned earlier. So if I was going to answer this, I would simply report it like this. I would say, A, my null hypothesis is that the mean is equals to 140. Again, you can put in minutes or not. I don't think it's really necessary. Let's add it here just to be thorough. So this would be the answer for Part A. In Part B, we're asked, what is the interval estimate of the population mean? So remember, population mean looks like this, at the 95% confidence level. Now, an interval estimate is also known as an estimation or a confidence interval. And that's a concept from Chapter 10, so let me show you how that works. So in Chapter 10, we're dealing with estimation. An estimation has the same basic idea behind it as Chapter 11 did when I was discussing the answer to Part A. In estimation, there's going to be a population parameter. Parameter just means any measure from the population. In our case, we're focused on the mean, so the population parameter is going to be the population mean, and again, it's unknown. Now, if we have an unknown population value or parameter, we could just go to the population and have a look and measure what this value is. But in this question, we don't have access to the whole population. Instead, we only have access to the sample, and so we can get a sample mean, and the idea is that the sample mean is going to maybe tell us what the value of the population mean might be. Now, I say what it might be because this sample mean doesn't necessarily need to properly represent the population. Think about it this way. Let's say in your class you have an average of 70. This would be the average, it's the population average, so that means that we've taken everybody's mark into account. Now what if I only take a sample of 3 people? I can find a sample mean based on these 3 people. Let's say that I find 3 people, somebody's getting a 50, somebody's getting a 55, and somebody's getting a 60. So here's 3 different individuals. I've got their 3 different marks. If I wanted to find the sample mean, I would add these up. And so what would that give me? I'm going to have, I believe it's 165. Let's see, 50 plus 55 plus 60 gives me, 165. That's my total. And because there's 3 of them here, if I want to find my sample mean, I would have to use this formula. So this is, 165 divided by 3, and that's going to give me 55. So this is a possible scenario. You could have a class where the average is 70, but maybe when you randomly select 3 individuals from the class, they are doing worse than the average. They're getting marks that are lower than the average. So your sample mean does not perfectly represent what's going on with the population mean. Now it might be kind of close, but in this case it's a little bit far off. We're going to have to make our decision about whether we believe it's close or far off later on in this case, but for now they just want to know what does the sample suggest about the possible value of the population mean. We do that in Chapter 10 with a formula, and the formula looks like this. It's x bar plus or minus z subscript alpha by 2, and then we need sigma over the root of n. This is my estimation formula of an unknown population mean. Now this requires that I know a few things. First of all, you can see that we have to have the population standard deviation, and I believe they gave that to us, so let's go back and check it out. And they show us here that it's a population standard deviation of 44 minutes. So we have that information.